Okay, we're going to talk about the homework here. I'm going to do 1 and 2 first. These are not too difficult. They're not really the word problems. I guess maybe the only hard part is finding the feasible region. So let's get started here. We have this, and then these two functions as well. And put a line in between. We need to sort of rewrite these two functions into a y equals mx plus b form. This guy ends up being y is less than or equal to negative x plus 11. And this guy ends up being y values greater than or equal to negative x over 3 plus 5. And if I graph them, so x is greater than or equal to 0, y is greater than or equal to 0, the negative x plus 11, and the negative x plus 3 plus 5, or negative x over 3 plus 5, so down 1 over 3. How did I mess this up? Something's wrong here. Not a great start. Oh, no, I'm fine. I'm just being stupid. Alright. Alright. So we have sort of two possible feasible regions. I'm going to want to, I guess, look at these guys. This one is less than, so I want the values below it. That doesn't do us a lot of good. This one is greater than, so that's this line. That would be the values above it. And so that's going to be this region right here. All right. So our intersection points occur at 0, 5, 0, 11, and 9, 2. And your maximum value, and when you plug back into this objective function for z, that will occur at 0, 11, you get 66, and at 0, 5 is your minimum value, you get 30. Okay, number 2. So again, we're given an objective function. We're given the 0, 1s. Those are pretty easy. We need to get our other two constraints into y equals mx plus b form. This guy's going to go to y values less than or equal to negative 2x plus 10. And this guy is going to go to y values greater than or equal to x plus 4. If I graph these, those two are easy. This one, y-intercept of 10 and sort of down 2 over 1. This is kind of funky with these rectangles. And x plus 4. All right, we have sort of two possible regions again, this guy or this guy. Look at it carefully. If its y value is less than or equal to it, this line is going to be below it, so this or this. If its y value is greater than or equal to x plus 4, that's going to be above the line, so that's going to be this region right here. Your intersection points occur at 0, 4, 0, 10, and 2, 6. Your maximum value when you plug into your objective function will occur at 0, 10. I got 20. And your minimum value will occur at 0, 4. I got 8. All right. So let's get to the problems that are probably tougher for you guys. That's going to be the word problems. So we're going to go to number 3 here, and this is a tough one. Get mine ready to go. All right. So a machine can produce either nuts or bolts, but not both at the same time. The machine can be used at most 8 hours a day. Furthermore, at most 6 hours a day can be used for making nuts, and at most 5 hours a day can be used for making bolts. There is a $2 profit for each hour the machine makes nuts, and a $3 profit for each hour that the machine makes bolts. How many hours per day should the machine make each item in order to maximize profit? All right, so we got nuts and bolts here. Specifically, we're talking about the hours making nuts and bolts. So I'm going to make X hours making nuts. I'm going to make Y hours making bolts. If you just want to call it nuts and bolts, that's fine, but being very specific. So our objective function is we're trying to maximize profit. We're getting $2 for each X for each hour making nuts and $3 for each hour making bolts. So 3 for Y. So our profit will be 2X plus 3Y. All right, so now for some constraints here. First thing it says, the machine can be used at most 8 hours a day. So however many hours we spend making nuts and bolts, we know that together, when we add that up, it has to be less than or equal to 8. All right, what else? Furthermore, at most 6 hours a day can be used for making nuts. So our X has to be less than or equal to 6. And at most 5 hours a day can be used for making bolts. So Y has to be less than or equal to 5. And there's no other information here, but there's 2 more constraints, and that's because we have to remember that the minimum amount of nuts and bolts we make is 0. So we got to have Y and X being greater than or equal to 0. All right, let's graph our function, and it might help to put this into a Y equals mx plus b form. Y is less than or equal to negative x plus 8. If I graph him first, here's 8, and then down 1 over 1. The x is less than or equal to 6, so I'm going to have this line come up. Y is less than or equal to 5, and then greater than 0 for x, and y greater than 0. We got a lot of possible regions here. I'm going to use these 2 guys right here. So x value is less than or equal to 6, it's got to be this way. Y value is less than or equal to 5, it's got to be down. And so it's either going to be this or this. I'm going to use this last one. Y value is less than or equal to negative x plus 8. So this line, if I have to be below that line and below this line and to the left of this one, that is our region. All right, looks like we have 1, 2, 3, 4, 5 intersection points, and they occur at 0, 0, 0, 5, 3, 5, 6, 2, and 6, 0. We want to plug all 5 of these points into our profit function to see which one works. I've already done that, and I'm just going to say that the maximum daily profit is $21, and that occurs at the 3, 5. And so when we are spending 3 hours making nuts and 5 hours making bolts, we make our maximum daily profit of $21. So maximum nuts per hour is going to be 3, and maximum bolts per hour is going to be 5. And this is weird to say. I mean, it should be hours making nuts and hours making bolts. I don't know why it says per hour. All right. Any question? Oh, yeah, you can't ask. All right, let's flip over. One more. Number 4. The liquid portion of a diet is to provide at least 222 calories and 108 units, whatever that means, of vitamin C. You cannot have more than 6 cups of drink X and 6 cups of drink Y. How many cups of each drink do you need to drink daily to get the minimum daily requirements for calories and vitamins? Okay, this is a confusing sounding question. So we're trying to minimize the amount of cups of each drink to get our required calories and vitamins. So we're going to let X be drink X. Well, specifically cups of drink X. And we're going to let Y be cups of drink Y. And our objective function is, I don't know, we're trying to minimize here. I don't know if I want to say profit. I'll just stick with P. We're not making profit though, but we're just basically trying to figure out how many of X and Y do we need to minimize our daily requirements for calories and vitamins. All right, so let's talk constraints. We cannot have more than 6 cups of drink X and 6 cups of drink Y. So our X values have to be less than 6 and our Y values have to be less than 6, or sorry, less than or equal to for both of those. We can't drink negative drink X and negative drink Y, so we have to have at least 0 cups of drink X and at least 0 cups of drink Y. And now for the last part, we got this funky table, and this is where this sort of opening information is going to come into play. So the liquid portion of your diet is to provide at least 222 calories and 108 units. And right here, it tells us how many calories, and I guess this is units of vitamin C drink X provides, and how many calories and units of vitamin C drink Y provides. So if we're looking at the calories, we have to have at least 222. So what that means is, however many drink X's we have, we get 74 calories per drink X, and we get 37 calories per drink Y, and we have to be at least 222. So this has to be greater than or equal to 222. Same deal with the units of vitamin C, which is we have to have at least 108 units of vitamin C, and drink X gives us 18, drink Y gives us 36. So 18X plus 36Y has to be greater than or equal to 108. We have to have at least 108 units of vitamin C. All right, we're going to want to put these in standard form before we can mess with it. This one right here will end up being Y is greater than or equal to negative 2X plus 6. And this guy right here will end up being Y is greater than or equal to negative X over 2 plus 3. If I graph these guys, we got the 0 functions. We got 2 6 functions. The X is less than or equal to 6. Y is less than or equal to 6. And then we got the 2 Y equals mx plus b looking functions. So negative 2x plus 6, down 2 over 1, down 2 over 1, down 2 over 1. And the negative x over 2 plus 3. So I'm going down 1 over 2, down 1 over 2, down 1 over 2. And which region are we talking here? We wanted y values greater than or equal to this function, so it's got to be above this one. It's got to be above this one. It's going to end up being this guy right here. It also follows these two rules. All right, intersection points. Once you get this far, the last part's pretty easy. Looks like we have 4 intersection points at 2, 2, 0, 6, 6, 0, and 6, 6. And don't forget, we are trying to minimize the amount of each cups of drink X and drink Y we need to drink. And so it doesn't say what the minimum would be, or it doesn't give us a thing to write it in, but our minimum amount is going to occur if I plug each of these into the P equals X plus Y. It's going to occur at 2, 2. So 4 cups, so that would be 2 of each. So 2 cups of drink X and 2 cups of drink Y will minimize the amount of cups we need to drink to get our minimum daily requirements of calories and units of vitamin C. All right, that was a tough one. There will be more of these practice problems tomorrow on our review sheet. So if you're still a little confused, hopefully we can iron it out tomorrow. Please email me if you have any questions, and don't forget to go on and do your daily quiz for today. Have a good day.